In this video, we're going to look at how the Pythagorean identities were established. So when given the unit circle, we know that the point where the terminal side intersects the unit circle has coordinates of cosine of theta comma sine of theta, which means that the length that we've traveled in the x direction is cosine and the length that we've traveled in the y direction is just the sine. We know that the radius measure is 1 because it's the unit circle, which is the hypotenuse of this right triangle that we have here. So just as the name implies, the identities that we're going to establish are a result of using the Pythagorean theorem. So if we use the Pythagorean theorem for this right triangle, it will be sine squared of theta, so sine squared theta, plus cosine squared theta equals 1 squared, which is just 1. And this is the main Pythagorean identity that all Pythagorean identities are derived from. So let's take a look at how we can use this to derive the rest of our identities. So this is pretty powerful because it says if you have the sine squared and the cosine squared, and then we're taking the sum of them, then it just sums to be 1. But we can also isolate this in terms of sine and cosine. So if I wanted to try and isolate my sine squared, I could subtract cosine squared from both sides. And I would have that the sine squared of theta equals 1 minus the cosine squared of theta. So I just subtracted cosine from both sides. Or if I wanted to isolate my cosine squared, I could just say cosine squared theta is equal to 1 minus sine squared, just by subtracting the sine squared theta from both sides. And that gives us two new identities, which are really just a manipulation of these. So if we ever need to substitute something in for sine squared, we could always use 1 minus cosine squared theta. Now, maybe sometimes we need things in terms of tangent. So if we wanted something in terms of tangent, we could just take this that we have here and divide everything by cosine squared. And that's going to give us our tangent squared. So if I divide everything by cosine squared theta, it's going to give me a new identity. Cosine squared theta. So as a result, now we have sine squared theta divided by cosine squared theta. That's just the tangent squared theta. Cosine squared divided by cosine squared is just 1, so plus 1. Equals, and then we know the reciprocal of the cosine is the secant, so that's going to be the secant squared theta. So now we have this identity, tangent squared theta plus 1 is equal to secant squared theta plus 1. And then just like we did with the last identity, we can split this up and get two more identities from it. So in this case, we have secant isolated. Maybe we want to isolate our tangent. So we can subtract 1 from both sides to get tangent squared by itself. So it would be tangent squared theta equals the secant squared theta minus 1, just by subtracting 1 from both sides. Or maybe we want another way to write 1. So we could subtract tangent squared from both sides. And then we would get 1 equals secant squared theta minus tangent squared theta. And as a result of just dividing everything by cosine, we get these three new identities. And then lastly, we can divide everything by the sine of theta, sine squared theta, to get our last set of identities. So sine squared theta. So when we divide everything by sine squared, we get 1 plus cosine squared over sine squared, that's the cotangent squared. And then 1 over sine squared is the cosecant squared of theta. So now we have these identities, and all we had to do was divide everything by sine squared. And then again, just like we can do with these, we can solve for the different parts of this and isolate the different parts. So if I want to try and isolate my cotangent squared, I can subtract 1 from both sides. So I'll have cotangent squared theta equals the cosecant squared theta minus 1. Or maybe I want a third way to talk about 1. I can say that 1 is equal to, and then just subtract cotangent squared from both sides. So cosecant squared theta minus cotangent squared theta. So from this single trig identity, which we just got from the Pythagorean theorem, we were able to establish 9 identities. 1, 2, 3, 4, 5, 6, 7, 8, 9 identities. So it's a pretty powerful identity, and it's one that we're going to be using all the time when trying to establish identities. So really, you don't really need to memorize all of these per se, as long as you can recognize how to get them from this single identity. If you don't want to worry about having to derive them every time, then you can just memorize all of these identities.